So everything is being recorded. And if people listen to this, we have a discount code for PASS, VC15GB Q6, that you can use to save $150 off of your registration at PASS, and you'll also be put into a drawing for a $300 Amazon gift card, and that may go up during the year because we get bonuses for people that are first-time users, or first-time attendees. Okay, it's 11 o'clock. I'm going to start in 10 seconds. Good morning. This is the May presentation for DBA Fundamentals. Today we have Kevin Klein with SentryOne. He's going to be presenting on how to assess technical quality of apps running on Microsoft SQL Server. Let me run over a couple of things real quickly. In fact, I'll let Kevin talk about this.
Oh, yeah, thanks very much. Can you hear me okay?
Sounds good.
Okay. Well, the VC is sponsored by SentryOne, my employer, and we are all about community. We give a lot to the community. You know, I was one of the original founders of PASS, and I was president of PASS for 4 years, and this is part of our DNA. We have on the kind of writing side of the house, we have a couple blogs, SQLperformance.com and blogs.sentrywone.com, with just loads of very technical, hard-hitting information. We have lots of videos at SQLsentry.tv. I believe there's probably around 16, maybe even more hours of query tuning advice right there on SQLsentry.tv. And then if you look at the second from the bottom, services, we've got also answers.sqlperformance.com. That's a website as well, where you can actually upload your query plans, and we'll give you free advice on those. So love to have you participate there as well. And of course, we've got a very free and very popular, and when I say very free, I mean we don't even ask for an email address, free query tuning product called Plan Explorer.
Thank you, Kevin.
Steve, we lost you there.
And we give away a $300 Amazon gift card from the pool of people that use our codes, and it may go up. Last year it started at $300, it went up to about $550. So anyway, and as always, we give away a $350 Amazon gift card for everybody that attends DBA Fundamental sessions here, and we give it away for one person. I'm sorry, I want to be sure I say that. From sessions here in the States and in Down Under. PASS has lots of other virtual groups. I've said that multiple times, but really try the other groups out. Lots of languages, pretty well every topic. Here's our sessions coming up. Down Under, we have a survey of Azure Data Landscape, SSIS Fundamentals Beyond 2016 features. Gail Shaw all about indexing, and anyway, I'm going to go ahead. You can subscribe to our YouTube channel if you want to, and that way as soon as a session is posted you'll know. Okay, other sessions coming up. Going to go on. Business Analytics Day in Atlanta, June 21st, and I took out the slide. I wasn't thinking. But the 24 hours of PASS is coming up. Just go to PASS and look for 24 hours of PASS. There'll be lots of great sessions coming up in the next 2 days. Our sessions are recorded, and this is where if you want to do a print screen of this screen, you will be able to find any scripts or slides and the link to the session at this location on our website, or you can go to YouTube, DBA Fundamentals. We're actually thinking about changing that name to make it a little bit shorter, DBA Fun, just to kind of make it a little bit easier to key in. Try to stabilize it across the board. So anyway, that's coming. Anyway, I'm going to pass it over to Kevin. Let me pass and make him the presenter.
All right, let me show my screen, and we should be good to go here in just a moment. All right, how's that coming through?
That looks good.
All right. Well, thank you, everyone. I know you have a lot to do, and you're busy, and you have a lot of demands on your time, so I really appreciate that you're spending time with us today. This session is about the buy versus build process, and you've got a product that may be coming in from outside the company. Maybe it's written by a dev team inside the company, and you want to know how good is the database design, how good is the code that is built into this system. And so this is a set of, it's demo heavy. We're going to go through a lot of demos, a lot of scripts that will check things, that will give you a quick indicator of what the quality is of this particular piece of code that you're going to possibly make a permanent part of your application stack. Or maybe you've already got one deployed and you just want to see how good is this thing really. I've got my suspicions. And so this is really good for DBAs or maybe developers who are new to the whole idea of an integrated design and with stored procedures and views and queries built on top of that. Give you a lot of indications about what is happening inside of your database and whether it's good or not. All right, so I mentioned that SentryOne is the sponsor of this event, and to make a long story short, we make the best of breed products for SQL Server monitoring, problem detection, and optimization. And we make it for the whole Microsoft data platform, everything from SQL Server, and this is our flagship product, of course, but also Windows, VMware, and Hyper-V, analysis services, and everything that you might have in the cloud as well. So we cover it all, and if you have needs in those departments, I hope that you will give us the time to see if we can provide a solution to the issues that you might be facing in your workplace. Now, also, I want to mention, we had this pop up earlier, so I'm not going to take too much time to talk about the different things we do for the community, but I do want to highlight our ebooks. And we have 5 ebooks right now. Each of these are quite substantial in size. The smallest is 320 pages, and they're written by some of the best and most well-known experts, the luminaries of our field, people like Glenn Berry and Paul Randall, people like Jonathan Cahias and Aaron Bertrand. So these are really, really useful bits of information that you can put to work in your environment. All right, I introduced myself in my past a little bit in relationship to the PASS organization. Please do take the time to connect with me on Twitter, on LinkedIn. I would appreciate any of those connections that you might want to make. I'm also on Facebook at KE Klein as well. I just enjoy getting connected with people out in the real world, I guess I could say. And so it means a lot to me. I started my career back in the 80s, back when relational databases were new, and have written a lot of books. My most popular book is SQL in a Nutshell. That's it's a bestseller, and so if you ever read the Nutshell books, I hope you'll take a look at that one. All right, so now, what are we going to talk about today? As I mentioned, this session is mostly demo, and we're going to look at 4 categories: the design of the database itself, the quality of the code that interacts with a database, and I'm a bit biased. This is primarily from the standpoint of stored procedures, of views, queries against the database. I'm not talking about, say, the C# or web code that runs against a SQL Server database. So this is the stuff built in. I'm going to spend a little time on system settings because this is something that vendors or products get wrong a lot, and also security. Don't let security be an afterthought. So often the DBAs think that the Active Directory team's going to handle that. The Active Directory team thinks the devs are going to handle that, and the devs think the DBA is going to handle it. And at the end of the day, nobody's paid attention to security. So make this part of your thought process as well. Now, one of the things that you may have noticed too is that with applications out there, that we go and buy, one of the things that the marketing for these applications will say is, hey, we run equally well on Oracle, on MySQL, PostgreSQL, and DB2, or something like that. And what they really mean is they run equally crappy on all of those different database platforms because they've got to get a product to market. So as soon as that code works, they pretty much stop. I mean, this is a universal thing that we see. It's very rare to find a company that makes a product for multiple data platforms that really tries to get performance really right. And so you'll see that this is a constant challenge. And even companies that only make products for SQL Server, a lot of times, they don't employ architects, they don't employ database administrators, they only have devs. And devs' job is to make good code, right? And I'm talking about the application code, not the necessarily the back end. And so a lot of problems creep in there. Now, if you have the time and the inclination, I encourage you to look at something called the CMMI, or the Capability Maturity Model. And this is something that helps us move from this kind of initial heroic efforts of the team, or the only way things get done in our IT organization, and helps us move to a more predictable, more stable, and controllable environment in which we can focus mostly on optimizing and adding value to the business. This is where we want to get. And most of us don't spend too much time there. It's, if we're in a well-run organization, we might be at level 2. Maybe we make it to level 3. But I rarely see it go beyond that. So if you are interested in taking it further than level 1 or 2, where your organization might be at today, read more about the Capability Maturity Model, and it'll give you a lot of pointers and tips about how to progress along that kind of lineage, if you will, of growing more mature in your capabilities throughout time. Also, if you're interested in buy versus build discussions, take a look at Richard Douglas's blog. He's written a lot on the topic, and there's a lot more than just the technology of an application when you're looking at buying it. So that's what I'm talking about today. I'm focusing on the technology as it relates to SQL Server. But there's things like support. There's, how quickly can that support team call you back and give you some real help, not just kind of take a ticket number and promise they'll get back to you. And there's pricing, and there's licensing, and there's service, and there's regional issues. So there's a lot more to it. And so Richard's blog goes into a lot of those topics that are beyond just the technology side of things. Speaking of which, let's jump in. So let's get to the technology, and let's start with red flags that we see right off the bat on database design. I'm going to talk about naming standards and why that can be an issue. Data type issues are a huge problem when people, don't really know much about the back-end database. Consistent use of primary keys, foreign keys, check constraints. This can have just a very powerful impact on performance, as well as how clustered and non-clustered indexes are created, or, as is often the case, not created. So let's actually jump into that and start doing some demo. All right, so database design, and again, all of this stuff is in the scripts, and so you'll be able to reuse all of this code as much as you like when you get the chance. And I also want to point out that this is not all my code. I stand on the shoulders of giants, so much of this code come from other great bloggers and writers in the field, people like Glenn Berry and Jonathan Caius and many others. So I tried to give credit wherever I could, wherever I remembered it. But one of the first things that you want to know is if anybody's using this old-fashioned SP underscore. This is a worst practice. Only the system processes inside of SQL Server user database should be named SP underscore. So what I like to do is take a look at all of the objects that are and what type they are. So the type description is, you can see here, whether it's a stored procedure or maybe a table or what have you. And I want to make sure that I don't, first of all, that I don't have that SP underscore used for any stored procedure. But the second thing I want to look for, particularly on stored procedures, is that they have a consistent naming structure. So sometimes we'll see something like all in one database, we'll see it says get customer details. Then we'll see, so here it's got the verb in front. Then we'll see something else where it says customer update, and then the verb is in back. And then we'll see create customer, and now the verb is in front again. And then we'll see something like USP update cost. So now they are actually, including abbreviations in the name, and they have a different or prefix to it. And so I'm looking for consistency here. It doesn't matter which of these approaches they take, but it matters that they're consistent. And if they're not consistent, that raises a red flag. That makes me say, what else is wrong in this system? Another huge issue that we have is when vendors use data types that seem like they are compatible with one another. And SQL Server doesn't actually give us a problem, it doesn't raise a red flag, but they aren't actually truly compatible behind the scenes. For example, integer and float, they both deal with numbers, so they look like they should be, fine, when in fact they are not directly compatible. So behind the scenes, SQL Server has to do a implicit conversion. And if you know your database design rules, you don't want to put a function on an indexed column, say in your where clause, because that causes SQL Server to not be able to use the index on that column. But whenever we have these implicit conversions happen, that's exactly what SQL Server ends up having to do. It has to do that implicit conversion, which is a function call, which means we can't use the index. I think the most common place that I see this happen is when the database is designed with, let's say, a varchar, but the stored procedure references that column in the database with an in varchar. Now they both got the word varchar in there, so they should certainly be compatible, right? But it turns out they're not. One is Unicode, in varchar is Unicode. It's got a 4-bit per digit, digital character represented, whereas the other is a standard 2-bit. Per character represented, and so they are not compatible. So here's a little stored procedure written by Jonathan Cahias that I really do like. What it does is it looks at the cache, and again, the more you have in your plan cache, the longer it might take to run. You can run it in production. It probably won't slow things down a lot, but it might just take a long time for this particular query to return results. But what this will tell us is if we have anything in the plan cache that has implicit conversions happening while we are executing. Now it's funny that I came back with nothing. The reason I say that's funny is because I actually loaded some queries in there that I knew had implicit converts, but I have a very small memory allocation, and so they actually aged out of the plan cache just in the few minutes that we've been talking here. 17 minutes since we started the session. But go to the database where you're interested in finding out and run this query, and it will tell you if you have any implicit conversions. This is very, very useful information. It is a problem. Now, a similar sort of thing is if we have a very, very different columns that have the same name. The columns have the same name in the different objects, but they do not have the same data type definition. So this is written by Ian Stirk. Let's take a look at this. Now, it will be pretty noisy. If you have a big database with lots and lots of columns in it, lots of tables with lots of columns, it will show you every place it sees category ID. There might be 30 tables that, or 30 different objects that have category IDs in there, and in one case it's a varchar, and everywhere else it's an int. So it can be really noisy. In fact, why don't we go ahead and go over to AdventureWorks just to show what I'm talking about here. So again, I run this one, and we'll see like some of these have lots of columns of a particular name, like title. And some of them are not null, and one of them is null. So it has to show you all of those for you to be able to perceive what the difference is. Here's person, and it's 128 characters in varchar, and the other is 50. So it can be noisy. There can be a lot of information there, but the idea is you want to know if the database design has very, very different, um, very, very different use of a given column of the same name. So like everywhere we see the email address column, maybe we've got a standard that it's going to be in varchar 50. Why is this one so much bigger? You know, so you can take a look at that and figure out if there's some kind of inconsistency in the way the developers created that particular database. Here's another one. So now what I'm going to do is I'm going to look through all of the different columns, and I'm going to see if they are oversized. You know, how much data is actually stored in these columns. This is really useful if you have a database that's been alive for a while and in use. So I'm going to go ahead and execute this one. There is another stored procedure I've seen out there, and I need to incorporate into this little toolbox that will actually tells you the difference in the amount of space consumed between two tables that have, let's say one has char 50 and another one has the same data and is varchar 50. Well, as you probably know, char will pad out until the end of that amount of space that it is that is set aside for that column and that data type, whereas varchar is variable character length, and so if it has any extra space at the end, it discards that and doesn't save it to the database. And so this particular script that I'm thinking of that I have to download and put in there, I haven't done it yet, will tell you how much space can be used. There's another one called SP space estimate space. I believe that's actually built into SQL Server that will tell you how much space is used by a given column, or I'm sorry, a given table as well. That's taking a little bit more time than I wanted it to, so I'm actually going to go ahead and move on. Now, another thing that can be a problem is indexes. This is a big problem. If we have tables without clustered indexes, this is a big deal. Now, for other database platforms like Oracle and MySQL, Postgres, they don't care about clustering nearly the same way that SQL Server and its progenitor, Sybase, they don't care about it quite the way that SQL Server and Sybase do. For us, it is really important. Well, for that matter, non-clustered indexes are also extremely important. That's where you get the speed on any of your lookups, any of your where clauses or join clauses. So here's one written by Davide Mori from Italy, and this will tell us, it's just going to take a look at all the different tables and their indexes. Let me stop the previous one because that's still running. And this will tell us just kind of the general situation with our indexes across the different tables. So this alternate district table, it only has 10 rows, but it is clustered. It has no non-clustered indexes. Then if we look at the customer table, it's pretty big. It's got 30,000 rows in it. It is clustered, and it also has one non-clustered index. Okay, that gives me a pretty good feeling, just very quickly taking a look at it. But look at this table right here, the history table. It's got, let's see, hundreds of thousands, 12,008,800,000 records, right? But it's a heap. So anytime we're looking up anything on that table, and the fact that it has no non-clustered indexes, again, big red flag. This company that I'm considering buying this application from, they probably don't know anything about indexing properly, or maybe on any database platform, but they definitely don't know it about SQL Server. Just to get a list of tables that don't have primary keys. Again, this is your unique identifier for each record in the table. And look at this, every table in here does not have a primary key. Okay, so now I know I've got a piece of junk when it comes to the database design here. In the same way, foreign keys are very important for relational databases. Foreign keys are what give the relation to relational. It shows how two different tables are related to each other. And one of the things that you might see often is that we do see situations where tables don't have any foreign keys, and they should. So once again, we know that customers are related to orders, right? Because that's who places the order, is a customer. But we have no foreign key between the two tables. That's not right. That doesn't happen terribly often, 20% of the time maybe. But what we do see happen a lot is that they haven't created a non-clustered index on the foreign key. Part of that is because there is a situation in which there is other database platforms will automatically create a index on, it's the default behavior when you create a foreign key. So that's one of the problems that you might see sometimes. Let's take a look at in AdventureWorks and see if that's the case. So we do have quite a few tables in AdventureWorks that have foreign keys, but no index on that foreign key column. So that also tells me that, we're missing out on quite a lot of opportunities there to have better performance. Since the server has been booted, I want to know how many times it's thrown, and the application has been running. I want to know how many times I've gotten missing index warnings. So let's check that one out. This uses the table sys.dmdb missing index group stats and is missing index group details. These are dynamic management views you have in SQL Server, 2008 or so, I think. And in AdventureWorks, we're not finding anything. Let's take a look in TPC. Okay. So we do have a situation here where we've gotten some missing index warnings. And so that lets me know that I might want to spend some more time doing some analysis on the indexing in this particular table or this database to see if it is effective. The indexing is effective. The inverse of not enough indexes is when you have more than one index on basically the same columns. This causes a lot of problems, and I've got the description of what the problem is here in the notes for the different scripts. But trust me, if you've got duplicate columns on the same thing, then this tells us that there is a performance problem, particularly around maintenance of the system. So I don't think we'll have any in the TPC database. Nope, let's try AdventureWorks and see what we get. All right, so there is one duplicate index in the AdventureWorks database. So again, that's good to know. That means that we're going to have some issues in the long run with keeping that up to date. All right, here's another red flag. If we find forwarded records in a database, this tells us that not only does the database have heaps, this tells us that the database actually has records that are larger than a single 8K data page. And that means SQL Server has to go behind the scenes and create kind of a pseudo clustered index called forwarded record pointers. And this is an enormously expensive operation. So here I'm going to check these different PerfMon counters. First of all, the number of deadlocks to me is important because there's only three things that naturally close a transaction in SQL Server. That's a commit, a rollback, and a deadlock. That's what will close out a transaction and finish it off. I want to know if I've got a lot of those happening. And it looks like at this point, if I look at the total value here, no, I don't have a lot happening. I do have a lot of full scans of tables. Now, that can be a problem. And again, you can see here I don't have any forwarded records. Full scans are interesting though because SQL Server will always do a full table scan on really small tables. If they're 64K or less, it'll always do a forwarded scan. So I would want to take a look when I see a number like this and see how many tables do I have out there that are really small. And if it's a pretty large number and people are doing selects against those on a regular basis, then it's possible that that's natural and normal and not a big deal. But if I don't have a lot of small tables in a given database, then this might mean I'm doing full scans on really important tables that should have indexes on them. Finally, these last three that I have here, batch requests per second, compilations per second, and recompiles. This is a kind of a shape that looks good to me. What you want to see is a lot of batch requests per second on an OLTP system. That means a lot of people are running batches against it. And then the number of times that the code is compiled, ad hoc code, stored procedures, what have you, is a decimal. It's a fraction of the number of batch requests per second. And then once again, the recompiles per second are a fraction of the compiles per second. If this number is anywhere near the size of the compiles per second, or it is greater than compiles per second, that's a red flag. That means that code is not written well, and it has to recompile before it can complete, and that means the code's bad, basically. Here, I want to know how many different kinds of lookup activities I have happening on my system. And so here in the customer table alone, look at this. I've got user lookups of almost, well, actually more than 500,000. And whenever you have a key lookup, that means you've got an opportunity to include a new index or possibly to include columns in an existing index. And when we think back to the original definition of the TPC table, and we remember that the customer table actually doesn't have any indexes on it, then this horrible high number makes sense to me, because that means that it has found more than 500,000 batches basically that have run since since it started collecting these metrics, that it would have benefited from having an index. That is really proof positive that this is not a well-indexed database. Now finally, the last thing I'm going to point out here, and this is some great scripts from Glenn Berry, you need to have these scripts in your library, is a bunch of queries about the physical layout of the database. And this is something that a lot of vendors just rely on SQL Server's defaults, which is a big fat mistake. In fact, SQL Server in the 2016 release changed a lot of the defaults, because the defaults are not good. They haven't been good for a long time. So when we pull this particular query, as Glenn says here, we want to look for things like, are all of the database files on drive C? If that's the case, that's a red flag. Is there only one file for TempDB? Yes. If that's true, then that is a red flag. So again, you can see all of these bits of information down here below, and we know that this is, this is a pretty big deal. Not well designed. All right, and then finally, again, one of the things that a lot of vendors do, they rely on the defaults, and the defaults for transaction logs are really, really bad. What they contribute to by using the defaults is bloating for virtual log files. Kimberly Tripp wrote some really good blog posts about in which she kind of definitively proved that if you have more than about 300 VLFs, you're going to see performance degrade, particularly on recovery. So you'll notice it during regular performance of your database, but it gets really bad when you're trying to recover a database, and it has to pass. It has to skip over all of these different VLFs throughout the log file. So this is a big deal. I've been to customer shops where they didn't know about VLF issues, and they had 50, 60,000 VLFs in their different databases. And so here we see AdventureWorks has 40, MSDB has 31, and so forth through all of my different transaction logs. But if those numbers are really big in your environment, you've got problems, particularly at the worst time. That is when you go to recover the database, and now instead of it taking an hour, like the amount of time it took to do the backup, it now takes 2 hours because of the number of VLFs you have in that particular database. All right? All right, so let's go back to our slides now. The next issue is code quality. And now I already talked about implicit conversion, but a lot of people don't realize that GUIDs are not something you want to see a lot of in your database. They have a specific and very valuable set of use cases, but the situation where they are not good is if they are used as your clustered key, your clustered index. They cause all kinds of problems. They are built to fragment. They cause fragmentation everywhere. They cause explosive number of page splits, which is a very expensive I/O operation. Since they're non-sequential, they cause any time you have a table scan to happen or a range scan of records, say between value A and value Z, it can't be sequentially read, and so it is contributes to huge amount of thrash on the database. And it's just hard to troubleshoot GUIDs because they're not values that the human brain was designed to hold. Show you a little bit about code caching and planned reuse. ORM created code has its own issues. Proper use of CTEs, cursors, and triggers. They're not bad, but we see them overused and used in ways that they are not best designed to be used. And then tempDB overusage. And I'll show you a little bit about that as well. All right, so again, let's jump over to demos. All right, let's see here. Make sure I'm in the right one. So vendor code quality. First thing I want to mention to you is that a lot of vendors don't support many versions of SQL Server. It's costly to have a big test harness, where you have a test matrix where you have to test, 8 versions of SQL Server and 8 versions of Windows OS and so forth. So a lot of times they lag far behind what Microsoft has released. And so let's say you're thinking about buying an app today. It's not uncommon, you're going to buy a inventory management system or a logistics system, and it's not uncommon for that to be written for SQL Server 2008, and it's not even in service anymore. So a lot of people, again, don't realize that there is a PerfMon counter that looks to see how much activity on the server is being executed that is actually deprecated. So when you pull this particular value out of DMOS performance counters, you'll find all of the different instances in which this is being, these different deprecated behaviors are occurring on your server. Now these are not, I would call these more like yellow flags. These aren't huge red flags to me, but I want to know if a vendor is lagging far behind in support for the latest release of SQL Server. What we find is that a lot of times vendors don't want to put any money into it if they don't have to. And what happens is you might have bought a product that was great when it was for SQL Server 2008, and here we are in 2017, and they're relying on the exact same code and haven't updated anything, right? Not a good deal. Now, triggers used to be good back in the old days. However, triggers are not a great way, all things considered, to instantiate a lot of your business logic. And so, again, this is kind of in the yellow flag territory. I don't mind if a system has a few triggers, but if it has thousands of triggers, I want to know, because that is probably going to be a system that has a lot of spaghetti code, that's really hard to troubleshoot and make sense of. And so here in this particular database, no triggers there. All right, well, that may be good, that may not. If I look in the AdventureWorks database, I see that there's a few triggers in here, and I can also make sense of them right away just by the title. So D employee, I can tell right off the bat that's going to be a delete trigger, right? And then when I look over at its characteristics, I can say, yep, it says that it is a delete trigger. And so I can clearly see that it's saying instead of delete, execute the code in this trigger. All right, that's not too bad. I can accept that for this system, and I can go forward with a pretty good level of confidence that this is not actually going to be a horrible design. But if I saw a multiple, not just 10, but I saw 100 triggers, yeah, that's going to be a really bad design. Now, another thing I mentioned from the slide is from the previous demo where I talked about this ratio of batches that were executed to the number of compiles that occurred, and then to the number of recompiles that occurred. That's one way to see if you've got effective plan reuse. You want to have the number of recompiles be a small fraction of the total number of compiles that are happening. The total number of compiles should be a fraction of the number of batches that are executed. But we can get more information on that too. So here what we're going to do is we're going to take a look at the plan cache and see what the total ratio are of different queries and so forth, stored procedures, that sort of thing, how many times they're used. Okay, so let's look at these as I scroll down here. And we can see that almost all of these have a use count of 1. Well, that's pretty low use count. What we would normally want to see is different of these bits of queries, or these different compiled plans that would be reused a lot, especially if they are prepared queries. That means they're stored procedures, right? And so we want to see these use counts pretty high. In this case, it's not a, again, it's not a big deal because this is a demo system. It's not doing real work, but there's there are situations where you will take a look at a system in, that's running and processing a workload, and it'll have thousands of objects with a use count of 1. And that's kind of alarming. All right, now active cursors. Why do I care about that? Long story short there is that cursors can be misused. There's a good way and a bad way to write cursors, and 90% of vendors do it the wrong way. If you're interested in learning more about that, check out a video that we have posted at sqlsentry.tv called Top 10 Things That SQL Developers Need to Know. And it'll show you how to write a really good, effective cursor that won't cause a lot of problems. So here I'm looking at active cursors, and I don't really have any active at the moment. But if you see these numbers and they're in the hundreds or thousands, that's a pretty good indicator that maybe they're over-relying on cursors. And you need to go the next step and make sure that that cursor code is of the good kind. And what you're going to want to look for there is that it will have the words local and fast forward in those read-only kinds of cursors where it's doing lookups on records. That's what you want to see. Most of them won't have that. Now GUIDs, as I mentioned, have lots of drawbacks. And the drawback isn't bad if you have a GUID column in your table and maybe you've set that up as a unique index, meaning it's an alternative primary key. But what is bad is if it is your only primary key and it is clustered. That is a problem. So let's take a look here. Nothing in AdventureWorks. Maybe I've got something in TPCC. Let's execute that. Yeah, so I do have one table, alternate district, and it's got a unique identifier, GUID, that is also the clustered key. It's going to be very problematic for that table's performance. Overuse of cursors. Again, up above we were looking to see if we had a lot of active cursors. Now this is going to take a look through the cache and actually, sorry, this one is a different bit of code that will find active cursors, but it looks for it in a different way. Take a look at that. And again, I don't have anything. We can also get a look at ratios of how many cursors are being used. So what this is going to tell me is, out of all the SQL modules that are loaded, how many of them are using cursors. So none of them are at this point. Well, that gives me a good feeling that we're not relying overly on cursors. And again, we can find active cursors in the cache. So again, if you're looking for that local fast forward that I mentioned a moment ago, we could see if that was the case here by taking a look at the code. So I'll take a look at AdventureWorks, nothing there either. Sorry, I didn't make sure that all of my demos produced the results. Now, overuse of TempDB. It's not bad to use TempDB in the sense of having temporary tables, but there are some situations where it is used for, temp tables are used for everything. And that can be a yellow flag because, we're relying on TempDB in sort of a brute force way, and we're not being really rational about the best use of TempDB. Remember, no matter how many databases you have active on a server, you've only got one TempDB, and because of that, the combined activity of multiple databases could really cause TempDB to be your most heavily utilized and most over-allocated, oversubscribed database. It could be really thrashed hard. So if these numbers are crazy high, then I go on and take another deeper look to find all of the stored procedures that might be using these temporary tables. So I'm looking basically for the ampersand here. And thanks to Tony Green, who contributed some code to my little script library here so that it looks for anything with angle brackets as well. All right, so let's take a look and run these. And I'm not sure if we'll get a result in this database. Let's see what that has to say. Okay. And we can flip over to AdventureWorks and see if there's anything over there. Execute that. Let's see what we get. That one took a little bit more time than I remember for some reason. And TPCC, which is the other one I was working with, is a bigger database. So, all right, so 58 modules, none of them are referencing temp tables. So, again, we're in a situation where looking pretty good in that regard. Save that. All right. Hey, I'm hoping we're going to get out on time here. Let's take a look at system settings. So again, system settings are things like the max memory and the minimum memory, things like optimize for ad hoc workload, all of the things that you can see when you take a look at the SP configure stored procedure, system stored procedure. Also, there's database level things that may or may not have been set, like, I don't know, forced parameterization or optimize for ad hoc workload. Also, trace flags. Those can be set for your server, and a lot of times the vendors don't tell you that their database needs a trace flag. It's been set at the server level, and that trace flag turns out to have a server level scope. So they've caused you to turn on a trace flag, and it's actually happening now to all of the other databases that are on my server. So they go in with the assumption that it's the only application on the server, when in fact it's not. And now the weird little tweaks and kludges and workarounds that they forced on your server is affecting the performance of everything else on it. So let's take a quick look at some of those scripts as well. All right. Again, Glenn Berry, he's a master of this sort of stuff. Get his whole set of scripts at SQL Server Performance.wordpress.com. But here, what we're looking for, again, he's got some great documentation on it. We're going to take a look at things like backup checksum default. We want to make sure that's enabled. Backup compression. Why wouldn't you want it? I mean, that's a good one. You definitely want to have that enabled. Less I/O on the database, faster backups, faster restores. It's all good. Cost threshold for parallelism. Recommendations vary, and they go hand in hand with the setting max DOP, max degrees of parallelism. But most people recommend for an OLTP system that you probably don't tinker with the max degrees of parallelism setting, but you do tinker with cost threshold for parallelism. My recommendation is to set it to 30. Others of my buddies will say 60 or more, like Jeremiah Peshka and Brent Ozar. They both say 60. But in my case, I'm a little bit more hesitant to go that high, and I set that at 30. That says if SQL Server thinks it can parallelize the query, only do that for queries that might take longer than 30 seconds. Don't do that for the really short and brief queries. So here, when we look down, we can see that everything on my server really, basically, is default. So these are, some of these we would want to change to get better performance out of our SQL Server. Now, here's another one we want to know about, active trace flags. If you're running on SQL Server 2016 or higher, quite a few of those trace flags actually got enabled in 2016 because that's just the way they should be. They should be set. But if you're running on any older version of SQL Server, there's quite a few that were not set, and you really want them to be in place. So here are a few trace flags that you do want to be enabled. For example, 2371 is a good one for any database that has large tables. It causes the auto update statistics threshold to move from a fixed number, which is 20% of the records in a big table have to change before it will update the statistics on the indexes. It lowers that in proportion to how big the table gets. So if you got a table that has 1 billion records in it, it's going to be less than 1%, or maybe 1% has to change, because that's still 1 million records have to change before it's going to go ahead and make that happen. I'm sorry, that's 10 million records. So this is definitely a good one to make sure is enabled. You also just don't want to get surprised by trace flags. So you want to make sure you know what all of the trace flags are. And in this case, I don't have any enabled. So, all right, no problem. Database level settings. Again, these are things that you want to keep an eye on. The different vendors will set some of these without you knowing about it. Conversely, they won't change anything at different times when they should have changed it. So let me go ahead and highlight this for execution. And while that's executing, I'll mention some of these things here. Here's a good indicator, for example. What's the database compatibility level? Sometimes it may be changed when it doesn't need to be changed, or conversely, you didn't really consider all the implications that relating to changing the compatibility level. Some people think that when you lower a database compatibility level, it causes the database to act just like that older version of SQL Server. Instead of SQL Server 2014, it acts like SQL Server 2012. That's not true. What it does is it simply ensures that the code written on SQL Server 2012 will run without breaking on SQL Server 2014. But all of the new features that are in SQL Server 2014, all of the query optimizer improvements, any improvements with memory handling or things like that, those are all alive and well, even when you're running under an older and lower compatibility level. That's one of the reasons why sometimes people are surprised that they get a lot better performance when they run, say a SQL Server 2008 database compatibility level to, on a much more recent version of SQL Server. Now let me take a quick check here. I see I've got some questions. Are the queries from the time the instant restarted? It varies. Some of those are from if those queries are coming from any of the dynamic management views, then that is going to be an indication that it is since the server restarted, Dave. But if they are coming from a different system table, then maybe one that relates to the database design, then no, that's actually all the time. That's not from the last time it restarted. Deepak has a question. He says, in our database, we have no primary keys or foreign keys. They're maintained due to overhead on the server. Well, if that's a small database, it's probably not going to cost you anything. If it's a big database, it's probably going to cost you something. And you might ought to capture a workload, create a second version of it somewhere, and test it with and without those, because that could be a big deal. All right, so here's another thing that a lot of people don't keep track of, is what are the, how many error messages are coming out of this particular system? So this is a big batch of code that comes from Pedro Lopez, who used to be on the SQL Server Cat team. And so let's take a look at this. Need to be aware of what the errors are that are coming off your different SQL servers, particularly your different purchased applications. Some of these are the kind of thing that, severity level 21, now that's a pretty big deal. I need to check that out. And not only 21, but it's 13 of them. Is this something that I should investigate further? Now, if the severity level is, say, 18 or less, those are all warnings. So you probably don't have to worry about those. But if it's 19 or higher, something's going on, and you need to get to the bottom of it. All right, and then the last thing, well, may not be exactly the last, but the last thing in this particular batch of code is memory dumps. So let's see here. Whoops, didn't get all of that code. This is and I didn't get all of the comment code there. I have actually had some memory dumps recently. This is a pretty big indication that there's something that broke really hard, really hard in SQL Server. You don't want to see too many of those. I've had people who ran this on a purchased application after they had done a proof of concept on that, and they had hundreds of these, and they had no idea that they were having memory dumps on a regular basis. That's a really big red flag. All right, so we're almost done. Trying to get us out at the top of the hour. Security. This is one of my biggest annoyances with purchased applications, because good security isn't a mystery. Good security just takes hard work. And so when I see vendors do things like they say, you have to give our application the SA password. What that really says to me is we are too lazy to write this application properly. And that is an enormous red flag right off the bat. Another thing you'll find in many applications is that there's no provisions at all for other kinds of roles. Everybody who uses the app is a super user. Maybe there is some kind of control in the GUI that accesses it, but what happens if that person actually downloads a copy of Management Studio and they connect using the connection profile of the application? Now they have the keys to the kingdom, and they can do all kinds of horrible things. Again, that's not hard to code around. It's just lazy. Same thing with sending passwords and clear text. Just lazy. So I look for these and a lot of other things. Now, when it requires XP command shell, that's a little bit different because there are a lot of useful practices around XP command shell. But it's one of those things where if it is configured, I want to make sure I know why. So here I've got two queries that look at some system settings. All right. Now the first one is just telling me whether XP command shell is enabled, and when it's 0, it's not enabled. But I could set that at particular times. These other ones in the second query here are other doors that may be open. So if you are in a more secure environment, maybe you're working for a government agency related to defense or homeland security, maybe you're working with a hospital that has some very secure medical information, you might want to check to make sure all of these other values are also set to 0, because those do open some doors and can cause some problems. And I haven't known a lot of database vendors who require cross-DB ownership chaining, for example. So check that one out. Another one that's really important to keep an eye on is how many times people log in with failed login attempts. SQL injection attacks are the #1 sort of attack vector that actually causes business lost business value, because the data is the most valuable asset of an information system. And so we want to know if these numbers, failed logins only, has hit 40,000 since yesterday. Boy, oh boy, somebody is attacking us and we have just totally dropped the ball and don't know if that is happening. So this, what it does is it's telling us that I am at least logging failed logon attempts, and we'll get an alert when that happens. Again, I want to know if there's some security risk around the administrator. So this will tell me how many people have that privilege. And it's not shared widely on this server, so that's good. I don't have that particular issue. How many of our members do we have that are in this group? And again, I don't have many, so that's all good. And then how about our different logins? Do I need all of these? Are there any that I can get rid of? Now, I should have wrote this code a little bit better. In fact, I thought I had included a version, but it looks like I haven't. I thought I included a version that filtered out anything that has this pound in the front. Don't worry about it if you see that pound. That's an internal sort of marker. So here we can see that there's myself, there's the system administrator for my company there, Mike Koval, and then there's SA. So this looks copacetic right now. And I can do this at the database level. I can find all the database users and what their particular roles are, find out that sort of information and see if there's anything out of the ordinary here. Again, it's all looking pretty normal. And finally, I can do a little bit of work to see what permissions are assigned to the specific server roles. Now again, this is if I want to, I've only got one role created right now. I've got public, but if you have lots of roles created, you want to make sure that they don't have too many permissions. The rule of thumb there is that you want to go with need to know. Only give permissions that are required for the work that that particular user role is doing, and don't give them more than that. So that's my red flag checks for security. All right, so hopefully we'll have a little bit of time here for Q&A. Got about 2 minutes till. Main things to look at, the 4 areas of those red flags. If you have another red flag and are willing to share that code, I'd love to hear it, and I'll include it in there, and put your name and blog and Twitter and all that stuff in there. Some of these checks are okay on a database that's quiet, that's not doing anything, but a lot of them really give you their most power when you are actually looking at a server after you've done a proof of concept, or maybe one that's even a working database. You see what's going on there. As I mentioned at the very beginning, I thank you for the opportunity to sponsor the group, the virtual chapter. And if you take a look at our tools, I'll be happy to show you lots of ways that our products actually identify these red flags and make it easy for you. I do have a recording of this already up at SQL Century TV. This is the full URL for the video, but if you go to SQL Century TV right now, this video is posted from a previous broadcast that I did. The scripts have changed a little bit, so the scripts that Steve is going to post for you on the on the DBA Fundamentals website will have a more recent version of those scripts. So I hope you'll take advantage of that opportunity. All right, so Steve went about 5 minutes in, and we were able to start about 5 minutes after. So I'll take a little time to answer some questions.
Kevin, it looks like there was still some from Deepak. He wanted to know, instead of using primary keys and foreign keys, he was using lookups in his ETL as an alternative. I guess that maybe you answered all of that, saying that that could be a problem once he gets larger. But if he's using it for ETL, that's probably large already. Mm-hmm. So.
Yeah, now the declaration of if it's just in the ETL process where you don't have primary keys and foreign keys, not a problem. But if it's in your functional day-to-day OLTP database, you really do want to have those foreign keys and primary keys with the proper indexes on those. Now, what a lot of people do to get around that, you said that it was a performance problem with maintenance. So what a lot of people do is in the ETL process, they have a staging database, and that database has no keys. It has no indexes. And because there is where you'll see the really big hit on performance for the maintenance of those keys. But once the ETL process, let's say it runs every weekend, or maybe it runs every night, whatever its schedule may be, after that process runs, that's when you rebuild your indexes and so forth, and make sure that you have that tip-top performance. Now, I'm sorry, go ahead.
I was just go ahead.
I was going to follow on that by answering Redwood's question there. He says, can you enable or disable foreign keys? Yeah, so here's the good news. You don't have to drop and recreate everything, not just keys, but indexes too. You can disable and re-enable these so that you can turn it off for a while and then turn it back on. And that is an easier way to do it in many cases compared to just dropping and recreating them. And also that can be the kind of thing, though, that you do have to remember that there is probably a next step, which is if you have disabled an index and then you re-enable it, you do want to rebuild or reorg that index as appropriate to how big it is.
Kevin, I kind of, my sound has been going in and out, and I've still got problems with it, so I didn't hear anything you said in the last 45 seconds. So.
Oh, okay. So I just answered Redwood's question.
Okay. Okay.
With that,
yeah, disable and enable foreign keys. Okay.
Yep.
I think that's about it, unless anybody else has any other questions.
All right.
I really appreciate it. Everybody go out there and sign up for our next session, Down Under, which is an overview of the landscape of Azure. And then we have a session on SSIS 2016. Then we have one on indexing by Gail Shaw. So anyway, we'll see you next time. Thank you. Thanks, Kevin.
All right.
Bye.
Bye.